and it's an Origin 20. These little amps have been a bit of a star of the channel, certainly helped to build the subscriber base. So if you came across the Headfirst channel because of the Origin mod, well, thanks for hanging in there. I'm going to revisit this because another one of these has come in for me to mod, and the owner of this amp wants the Plexi mod. So I thought I'd take the opportunity just to kind of revisit a few things that are often questions that I get with respect to modding one of these. All of the 3 mods that I have done on here, they're all really similar in terms of their kind of overall architecture. So I'm not going to kind of go through the whole thing because I've already done a video on that, but I will kind of go through and point out a few of the things that I think are helpful in terms of modding one of these if you're thinking about doing it. Now, the first tip I'm going to give you is by far the easiest and safest way of doing the mod is to actually remove the PCB. I know I have said that you can mod this without removing this main PCB. Yeah, I've done it. And it does save you some time, I guess. But if you really want to do kind of a more pro job, it is better to remove the main board. So what I might do in this video now is show you how to do that. So the first thing we need to do is actually get rid of these tubes. The PCB is actually screwed in with these screws that are holding the octal sockets in place. So you can unscrew these. These are actually self-tapping screws that go straight in to the octal tube socket. Make sure you take lots of photos of the insides of the amp, because when it comes to connecting this all back up again, you'll want to use those photos. Otherwise, you won't know how to connect everything back up again. So take photos of all this stuff, right? See all these color-coded wires. Obviously all of this as well. I mean, a lot of this changes anyway with the mod, but all the stuff that you need to put back to stock, you want to make sure you keep it that way. Okay, so the next thing we need to do is I'm going to pull all these spade connectors off. Now, don't be tempted to just kind of pull the wire. You can, but sometimes you'll pull the wire off and the spade connector, terminal connector, will still be there. So you just use some pliers and grab the actual connector itself. It's a much safer way to do it. Come on. Tight. That's all the main ones done. Alright, the actual ones. Now these will just clip off. And just pull them off, right? Use your hands for that. Just give them a little bit of a wiggle. They click in, but they pull out, without too much drama at all. Okay, so the board's pretty free now. I think there's nothing left, so we now need to take all these out. Now, these are pretty heavy duty, right? These screws that are into the standoffs. So Marshall haven't, and they've all got washers on them. Marshall haven't skimped here in terms of making this PCB really secure in the chassis. Alright, so I'll give them full credit here. You've got to be careful not to strip these. Some of these are actually in, I've got a little dab of Loctite or something on there to make sure they don't come loose, but as a result, if you're not careful, you'll struggle to get them out, and then you'll strip them. So you see I'm kind of like, I'm applying a bit of force here to make sure that I get a good purchase on the Phillips head, and just dislodge that first bit. Once the kind of the Loctite that's holding them in, once that comes loose, she's all good. This should be the lucky last. While this is out, it's worth pointing out, this is actually the ground point. So if you look really carefully at this one here, you can see the solder mask here is exposing the the board, the actual copper underneath the ground plane, and that connection there, that screw connection there to the chassis, is giving us our ground connection for the board. So once those are out, this will just lift straight out. Okay, so it's not that hard to do. And with this removed, pulling the components out that you need, leaving, holes, leaving solder pads in place that you need to put new components in, it's a hell of a lot easier. And these are all wave soldered by a machine. So, yeah, this is the way to do it, guys. Okay, let's have a look at how to remove these components, right? I'm just going to demonstrate a couple of ways of doing it. And when I say a couple, because one way I think is the sort of the easiest, but it does destroy the component, in this case the resistor. The other way, you kind of can salvage the resistor, but honestly, what's a resistor cost? Kind of not worth it. So here's the quickest way, and let's call it the safest way, because it's going to be the safest way in terms of preserving the integrity of your printed circuit board. So I'm just obviously just cutting them off, right? Cutting it straight off. Now throw that away, no good to you anymore. And then what you can do is the legs, these little legs that are left in the solder pads, you see how they're bent over, right? On all these boards, the resistor legs are bent over. All the component legs are. And these kind of, done by a machine. So it's actually really hard to pull these out from the top. It's possible, but it's a lot easier to get them out from the bottom. So take some, this is kind of, it's lead-free solder, all right? So it's actually really hard to work with. So what I'll often do is just mount a little bit of, let's call it good solder on there, and grab the leg and just pull it out. Okay, and you can clear that hole completely with a solder sucker, where this guy here now, right, completely clean and clear and ready to go. and obviously, you know, rinse and repeat on all the others. Now, the other way to do it is, say you're pulling them off, you're pulling them out from the top, and you want to try and keep the resistor. So do the same thing. Melt some, you know, leaded solder, and grab the resistor with your pliers and just pry it back and forth gently while the iron's still on there, and just wiggle it, and you'll be able to pull it free like that, and it's kept the leg of the resistor intact, right? But you know, all that wiggling is to try and straighten that out, and I guess you could pull this back a bit to straighten it out before you do it. It's a lot of hassle if you know, but if you really want to keep these resistors because you want to reuse them, some other thing, then you can do it that way. The first method, and you can pull the whole resistor out like that. First method's safer in terms of, you know, it's less stress on the printed circuit board. Okay, so this is what the stripped board looks like, and you can see all the stuff that needs to be taken off. Here, this guy, 3 here, all of these, this cap, this resistor here, 4 resistors and a box cap there, 4 resistors, another cap there, this cap here as well, and the rest of the board is stripped, and you can see I've cleared, just for neatness really, I've cleared out every single solder pad here. Some of them will be reused in the mod, others will never be used, but I think it just looks, you know, it's a nice way to leave the board. So this is now ready to kind of just like run the routing underneath the board that I need to. That's all detailed in the original video I did on the Plexi mod. I think what I'll show you next, because I'll just kind of crack on and do this. What I will show you though is the changes that need to be made to the front board as well, which are quite specific for this particular Plexi mod. So here's the front board taken out of the amp. Okay, so you know that this is the board that the pots are mounted on, obviously. So to take this out of the chassis, you just unscrew all the nuts that are holding these pots in on the front of the chassis and the jack. Clip these off, it'll come straight out. And for the Plexi mod, you need to remove the gain pot, the tilt pot, the master, because this amp will have a post-phase inverter master put into it eventually. And I redo the presence pot as well. You don't have to do this, but I do rewire the presence pot in this mod to make it like an old vintage Marshall with the 5K linear and a 0.1 microfarad presence cap. So getting these single pots off here is actually pretty straightforward. With these pots here, you can just kind of like, you can literally mount the solder and pull them off, right? And then you can clean the holes up. Getting this one off here, which is one of these double, you know, like push-pull style arrangements, it's a bit harder, but by far the simplest way to do it, unless you've got a really good desoldering gun, is just clip it off, right? So this was literally like this, and I, you know, got in here with my cutters and cut it off, right? And it'll come off pretty easily when you do that. And then what you're left with are just little stubs that you can just, you know, again, like we did with the resistors, you can just, you know, hold, and pull them out, and you'll have a nice clean. I mean, we don't need to reuse these pads, but it's nice to just have the board nice and clean like that, yeah? So, simple as. Okay guys, this board, the main board here, is ready to go back in the amp, I believe. So I'm just going to go through these changes one more time, because now I've actually put the kind of new components in, right? So obviously before we just ripped everything out that we need to. R69 is a 2K7. Okay, this is the cathode for V1A. This is a 0.0022 coupling cap. Now I've tied the grids together here, so pin number 2, 3, 4, 5, 6 and pin number 7 tied together. Okay, and I'll show you why when we get into the guts of assembling this. Basically I want to have, you know, the treble channel and the normal channel permanently jumpered, rather than using the push-pull function. I'm going to use the push-pull function for a switchable bright cap. This is standard. This is the 820 ohm resistor for the normal channel cathode. So normal channel on this side, treble channel on this side. And this is a 100 microfarad bypass cap for that. In the original Plexi mod, I just put it over the top of that resistor, which you can do, but I realized second time around that there's some free solder pads here that I could use to make it easier. So I've got the positive side of this cap at the top of C37 and the ground connected to the bottom of R65, I should say. Okay, so again, in a stock Marshall, this is normally going to 220 or 330, but 100 is, as I said in the first video a couple of years ago, way big enough to give you that big kind of, you know, base channel. Let's call it a base channel in the Plexi. 100k cathode resistor here. This is going into R59, and then we bridge this across to give it a ground reference. R54 is a new, this is an 820 ohm, and this is the cathode resistor for the gain stage that is coupled to the cathode follower, and it's got a 22 microfarad bypass cap. That's stock. It's already in the amp, so you can reuse that. I have removed R49, which is different than what I did when I did this a couple of years ago. This is for the new present setup. Okay, so this might have been an oversight actually in the first time I did this. It's always interesting when you do something for the second time. And I'll show you when we get to, again, kind of wiring the presence pod in, why that is. So this is the 4K7 resistor that's normally in the standard amp, and is the kind of the right at the tail of the phase inverter. We don't need that because we're going to use a 5K linear pot at the tail rather than 4K7 resistor. I've also replaced this. These are the two plate resistors for the phase inverter, and in the stock amp this was 100k and 100k. So normally you have 100 and then 82k in a standard Marshall phase inverter. So I have changed that to 82k, and I've realised that R55 here is a 220k resistor. I'm going to change this to 100k. Okay, again, just moving this back to a stock Plexi. This is the plate resistor for that third gain stage. Well, let's call it, the gain stage that's coupled to the cathode follower. What is normally V2A in a 1959 Super Lead. I realised I've just missed this, so I'm going to change that out to 100k. That's R55. Okay, so let's do that. Okay, picking this back up again. Change out that 220k for the 100. So I think we're all good here. If I miss anything, I'll be sure to holler. Now, let's have a look at the underside of the board. This was detailed quite extensively, I think, in the first video. You've got to run a wire, this pad here, closest to V2, across to this side. Okay, so on the front of the board, it's actually running from here, the top of C33, to this side of C30. Okay. And you've got to tack in. Pretty hard to get them in here, right? But if you're careful, the reason is because I've just left the headers on there. I guess you could pull all this off and you could solder those into the pads that are left, but honestly, it's not worth it. So these are to run into the inputs of the 2 channel volumes. Okay, right, let's go through this completed Plexi origin. I just want to kind of highlight, again, this has been detailed in a previous video, so I don't want to repeat myself here, but I want to talk about some of the kind of things that have been updated in terms of the mod. Let's call this revision 2 of the headfirst Plexi mod. I have made a couple of improvements, I believe, to the functionality of this thing. I do want to highlight a couple of things that maybe have to be super clear with how this is set up. So got a 2K7 here, which is the new cathode for V1A. You got to pull this the stock electrolytic cap that was here. This is a 0.68 microfarad, right? Again, this is all detailed in the first video. These are, the reason I want to highlight this is that these caps can be hard to come by now. That's a 50 watt Nishikon 0.68 microfarad, and they end of life these a little while ago. You might be able to find them in a different voltage, like 100, which will be fine. And the footprint probably still be okay. If you can't get those, you can use a cap like this as a bypass cap. And this is one of these kind of MKT 1813, 1813. This is an Aero one. I've got a whole stack of these. This is a 63 volt, 0.68 microfarad, and it's obviously an axial cap, not a radial. So what you would do with this is you would have to kind of sit it over the top of, let me get my fingers out the way. You'd sit it over the top of that 2K7 resistor and solder the legs of it to the legs of that resistor like that. That would be the way to do it. So I just want to kind of point that out because they can be hard to come by, right? Let's talk about the things that are a little different this time around. I'm going to tilt this up a little bit. It's a 4700 picofarad bright cap, and you can see I've ripped out the stock gain pot, so I can use my new push-pull here. It's a 1 meg audio taper pot, and my switch here is just bringing this bright cap in and out. Now we all know, right, a bright cap you would wire between the input lug and the wiper. So the switch here is just interrupting that. It makes the amp super useful. I'll demo this when we have a look at some tones in here. Okay, so this is different than the last time around. The last time I used the push-pull pot to jumper the channels. Now, what I've done is just permanently jumpered them by bridging the grids of V1A and V1B, so the treble channel and the normal channel, if you like. And, you can deactivate the normal channel just by putting the volume on 0. Simple as that. While I remember it, let's talk a bit about voltages. The voltage droppers in here. This is a 2.2K, this is a 4.7K, that's stock. And I just replaced this one here. I think it's a 7.5K in the stock amp to a 10K. Kind of make the the voltage drop from V2 to from V2 to V1 to be like a standard Plexi would be, or a standard Marshall. The voltages in here are pretty good now, actually. I don't have this ready to fire up, but I found that if I had this a 10K and a 10K and a 10K like standard Marshall, the voltages at V1 are too low. So low that you start to get a DC voltage on the grid, and so you'll hear it when you move your guitar volume, it'll sound scratchy. It's always a sign, right? You've got DC on your guitar, and then DC is coming from the grid, and that happens when the plate voltage on the triode gets too low. So the plate voltage on here, if you have 10K, 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 was about 110 volts, way too low. You need kind of 130. Anything above that, you'll be safe. But I think it's worth changing this one out and put the 10K in there. Sounds cool. This is the input to the phase inverter, so by tacking this extra bit of shielded cable onto the standard connector here, again this was detailed in the first video, and I think I left the cap in here and I brought this in on this side of that standard cap, which is the entry to the phase inverter. I wanted to replace this cap. It's 100 nanofarad in the stock amp, which again is kind of too large. This is 22 nanofarad or 0.022 microfarad, and you can see I've used an axial cap here, one end in the top pad, and then I'm connecting that piece of shielded coax just to the top of it. What else can I tell you? I changed this. It's probably worth mentioning. I think in the stock Origin 20 it's 100k and 100k for the phase inverter. So 100k and 82k is more of kind of, again, standard Marshall phase inverter. The post phase inverter master, in the first iteration I did shielding all the way around. This time I just did shielded cable from the wiper to the grids. This is perfectly fine. It's silent, it's noiseless, so you can save yourself some time and hassle here by just using unshielded from the tops of R41 and R42 into either side of the input to this pot. This is a 250k audio taper, dual gang. Okay. And the presence pot wired like a normal presence pot. So again, that R49, you would lift that resistor out completely and use the black as your ground, the white as the input into the presence pot, and that's a 0.1 microfarad presence cap. This shielded coax here, this is a 100k resistor, which is the new, we create the cathode follower that drives the tone stack in the mod. This is core to the mod. You'll see this in all of the mods that I do. But in the Plexi mod, you need to ground this at this end as well. Now, normally with these shielded coax runs, of course, we only have the coax grounded at one end. You don't ground it at this end. That's just because you're using it as a shield, right, for protect against noise. However, your tone stack here gets its ground. The mid pot needs to be grounded, all right, and the mid pot gets its ground from this. So the white is the signal line. Run that to the top of this 100k, which is sitting in position R. Was it R69? Yep. R59. Yeah. R59. Okay. And go. So this is the white one is the signal line, and this is running to the top of this 100k, right, which is in R59. Okay, and then the shield of this, you've got to connect it. You can connect it. You've got to bridge the resistor right next to it. It's R58. I just bridge that because it then creates a ground for R59, because you need this side of this 100k resistor to be grounded. And if you jumper these pads here for the where R58 was when you pulled it out, that grounds that side of the 100k. You need to connect the shield of this to that ground, and then that'll give you a ground on the mid pot, and your EQ will work. You'll know that if that's not correct, because you'll move the EQ and literally nothing will happen. Okay guys, look, it's kind of the main elements of this in as kind of extra information on top of the first video, and it outlines the main change that I made in terms of the functionality here, right? Bridging these and having your push-pull as your bright cap. It's easier to use, more functional, sounds better.